Hey everybody, this is Gregory from Dapp University. So welcome back to this multi-part tutorial series where I'm showing you how to build a full-stack blockchain application step by step, all right? So in this video, we're going to continue on with the smart contract and show you how to purchase products in the blockchain marketplace, all right? So before we get into that, be sure to subscribe to this channel if you haven't already. Click the like button down below, all right? And as always, if you want to learn how to become a highly paid blockchain developer, you need to join my free training on my website over at dappuniversity.com/bootcamp. All right, in the last video, we created a product, right, inside the smart contract. And in this video, we're going to allow people to purchase the products, okay? So we're going to test for that. But really quickly, we're going to test that we can actually read products out of this mapping, right? We're going to be able to fetch products. So it's sort of like create, read, and update. That are going to be the main functions of the smart contracts when it comes to products. So let's make sure we can read the product out of this mapping, right? So let's go to the test really quickly. We're going to create a new test down here. Just below it creates products, we'll just say it lists products. And let's just actually copy this. So we're not just writing code over and over again. I'll do this. Say it lists products. All right, so inside of here, what I want to do is basically say const products. I want to fetch them from the blockchain, from the smart contract. So I'll say await marketplace products. All right, we're just going to call this function right here. All right, products right here. And we're going to pass in the product count, which we set in this before action right here. So product count. All right, so let's just do that. And we'll check that the values are correct. So I'm just going to copy this so it looks kind of the same. We'll say, instead of event, we'll change this to product. All right, and this should actually be product, not products, sorry. So, like I said earlier, we had to fetch products out of here one by one, which we do like this. Product equals product count, all right? Or product equals this product with the index of product count, all right, or ID. All right, so let's run this test. Should just pass like it is. Truffle test. All right, it worked. So let's go back into our test. Looks like everything's fine here. So now let's say that it also purchases products or sells products, okay? So let's just clear this out and we'll fill out this test. But simultaneously, we're going to create a new function inside of the smart contract to actually facilitate the purchasing process. So down here, I'm just gonna give myself some extra space so you can see this on screen just fine. All right, so we'll say function purchase product. We'll pass in an ID. So we'll just tell it the exact ID of the product we're going to purchase. We'll say pause public. And the first thing we want to, we're going to do several things inside of here, right? We're going to have to say, we're going to fetch the product. All right. We're going to fetch the owner. All right. We're going to make sure the product is valid. Like it can be purchased. We're going to basically purchase it. And we're going to trigger an event. There's going to be a lot of steps inside of here, but that's high level what we're going to do, all right? So let's actually just do the purchase like this. We'll do the basic part first. So first we want to fetch it. We'll just say product equals, actually do this. Product memory, product equals products ID. All right. So let me explain this. Essentially what we're doing is we're instantiating a new product, that we created here, this product struct, like this, but we're doing it in memory, right? We're having a new copy of it, not the one that actually exists in the blockchain, and we're assigning it to a local product variable with this underscore, all right? And we're just saying, hey, fetch that particular product out of the product's mapping and, create this new copy in memory like this, okay? That's why we have this memory keyword. All right. So next we want to actually fetch the seller. So say address seller equals the product owner. Because if the product hasn't been sold already, that's who the owner is the seller. Okay. So now we want to we won't check for validity just yet. We'll do that last. Let's actually transfer the ownership. So that's what we do whenever we purchase it. So we'll say transfer ownership to the buyer. So we'll do that like this. We'll say product owner now equals the buyer, which in this case is going to be the person who is calling the function. So that's going to be msg.sender. And I explained msg.sender here, right? And now we're going to mark it as purchased. So we'll say product purchased equals true. We're going to update the product in the mapping. All right, we'll say products ID equals product. All right, so this product that we've edited, basically we've created a new copy in memory here. We have assigned a new owner, but we've tracked the seller before we did that. And then we, transfer the ownership. You said that it's now purchased, and we put it back in the products mapping like this. All right. So now what we need to do is actually pay the seller. So whenever we call this function, we're going to actually send in some cryptocurrency to purchase the product, right? We're not just going to transfer the ownership. We're also going to pay the seller, right? Pay the seller by sending them Ether. All right. So you're going to see this in the test, but essentially we can pass in Ether with this function call, okay? Actually just illustrate it before I do it, okay? So, because this can get kind of confusing. But basically what we're going to do is we're going to do the function like this. We'll say result equals, we're not going to run this yet. I'm just going to show you high level what it looks like. Await, marketplace, purchase product. We're going to use product count as the ID. And so that, that's the only argument that this function accepts is the ID, right? But we can additionally pass function metadata like we did here. All right, this is from seller. All right, but we want to say from buyer. All right, it's going to be a new account. And this is the from. But we can also send Ether in with this function call. Okay, so we can give it arguments, but we can also say, hey, send some cryptocurrency. And that's actually how we're going to pay for the product. And we do that with value. All right. And this value is going to be, the price of the product. In this case, 1 Ether or, this many Wei. And we can just use that same value from the test, right? This is the product price. Let's just pass in the value like this. All right. So that's the actual product price. So that's msg.value, okay? So that's going to get sent in as function metadata, and we can access that inside of the smart contract like this. We can basically just say msg.value, all right? That's going to be the amount of Ether that's sent in with the function call. Okay, so now we want to actually transfer that value to the seller. So just do like this. We'll say address seller, all right, which we dashed right here. Click transfer. All right, msg.value. Boom, easy as that. That's how you do it. That's how we pay the seller. We basically take the Ether that came in and send it to them that way. All right. So there are a few things that we need to do in order to make this work. We need to modify this function. First, we need to make this function payable. All right, so Solidity won't let us send in Ether with a function unless we've used this payable modifier right here. That's what allows us to do this value metadata, okay? And likewise, we need to make sure that this seller address is payable. So we'll say payable here. Sorry, payable. And we also need to make sure that that is declared payable everywhere else inside of the smart contract where we, use this address. So address payable is a modifier. So we'll say address So let's see here. Here, these two places. All right, so address payable. All right, and then address payable. So it's really critical that you get these right or else it's not going to work. And then also, yeah, that's how you do it. So that's how you transfer Ether to the seller. You got to make sure everything's payable. All right. So last, we want to trigger an event. All right. So now what we want to do is use this product created event, and we want to basically say product purchased. And we just really want to use the same values as this event. We just call it a different name. All right. So just like this, you can trigger an event, copy this, and just change the name. Product purchased. All right. And the last final thing we're going to want to do is make sure this product's valid. We'll have some requirements just like we did up here, but we're going to do that last. Let's go ahead and write some tests just to make sure that all this stuff works. All right, so first, let's just truffle compile. Make sure I don't have any syntax errors. I've been bad about that in the previous videos, so we'll go ahead and run that basic check first. All right, so we got some issues here. Let's see. So undeclared identifier, did you mean name? All right, so that doesn't know about the name. So we'll need to actually do that. We'll say product name. All right, and then also product price. All right. That's just a copy and paste error. Let's try it again. Truffle compile. All right, so it compiled properly. Now let's write some tests to check on this behavior. All right, so the first thing we did was set up the result, okay, and we wanted to see that yeah, we could pass in the buyer, and we could also pass in the value. So that illustrated how that worked, but we're going to use that as a starting point for our test. So we'll say success. Buyer makes purchase. All right. And what we want to do is go ahead and check these logs just like we did in the previous test to make sure that all this info was logged out properly. So I'm just going to copy this. We'll say const event. All right. And we'll say check logs. So inside of the logs, we want to make sure that the event ID is the same as the product ID, so that's good. The name is right, the price is correct, the owner is now the buyer, not the seller. All right, and purchased is now true. All right, so let's run that test. Say truffle test, and I'll pull this up so that you can see it, make sure it's not cutting off from the screen. All right, so it looks like there's an issue here. We got one failure. Expected purchased, see it expected true but got false. So let's make sure we updated that correctly. All right, so that's another thing we need to change. So purchase should be true here in the event. So that was my fault. Sorry, guys. We'll run the test again. But hey, that's why we write tests. We make sure that stuff works properly. All right, it passed. So that's good. We checked the logs. The logs are correct. So the next things we want to do, let's see here. Let's check to make sure that the seller received the funds, all right? Seller received funds. So this is gonna be a little complicated. The first thing we wanna do is actually, well, we wanna do this. Basically, we wanna see how much they had before, and then see how much they had after, and make sure that the difference is the same as the product amount, right? So now you'll see you'll see like in Ganache, these balances are changing, and it's going to change all the time because we're running these tests, and Ether is going to get transferred anytime we sell a product. And you also see these little tiny amounts go down. That's because these are paying for gas fees whenever we're calling functions, right, or deploying smart contracts or anything like that, right? Whenever we list the product, we're going to pay gas fees. Whenever we purchase a product, we're going to pay gas fees. So basically, the Ethereum network requires you to pay gas anytime you make a transaction. We'll talk about that more whenever we build out the client-side application. You'll be able to see it more explicitly in MetaMask. But just know these values are going to change like crazy. So we don't know what they're going to be before we run the test, so we need to check. We'll basically just say, track the seller balance before purchase. All right, so we'll say let old seller balance We'll say old seller balance equals await. Web3, we can just check the balance like this. Web3 ETH get balance. And we'll say seller. All right, let's say old seller balance. Let's format it. Web3 utils. We're going to convert it to a big number. All right. So we want to use big numbers because we want to use big number addition whenever we do the math. All right. So let's say let new seller balance. This is going to be after the transaction has taken place. Let's say new seller balance equals await. Let's just do this actually. Basically just copy this. Change old seller balance to new seller balance. All right. So now let's say let price equals Web3 utils two-way. Say 1 ether. All right. This is the price that we paid for everything. All right. And then price, we'll convert it to a big number just like everything else. Say new Web3 utils being, say, new seller balance. Oops, I made a mistake here. So this should be price, sorry. And also, I don't know why I'm saying await here. So whenever we create a big number, we say new, sorry. Same thing up here. So I'm just gonna, if you wanna just pause the video really quickly and just look at this screen to make sure your code is the same, right? That might be helpful. All right, so yeah, I'm gonna await, say new, await, new. All right, same thing here. All right, so now what we wanna do is basically, let's just log these out. So let's say console log, say new seller balance, or old seller balance, new seller balance, and then price. All right, and let's just say truffle test. Let's just see what gets logged out to make sure that we formatted everything properly at this point. Because what we're essentially going to do is do some math and make sure that the new seller balance is basically the old seller balance plus the price. Okay, but we want to make sure that we've set all this up before we start adding things together. All right, so here's a big number, here's a big number, and here's a big number. I can't actually tell what these are by looking at them, but I'm going to assume that they're right. So let's try to add them together in our test and actually create the assertion. So we'll go back here and say const expected balance equals old seller balance add price. So you add as a function that exists on big numbers, which we have here. All right. So it's going to be the expected balance. And we'll finally check. We'll say assert equal new seller balance. And then it's the expected balance to string. All right. So new seller balance. Let's actually do this to string. Let's just convert them both to string just to make sure. All right, so let's say truffle test, and hopefully this works. All right, it passes. So we now see that the seller received the funds whenever the product was sold in the marketplace. All right, perfect. Okay, so we've made pretty good progress. We've tested for a lot of the core functionality inside of this purchase product function, okay? So the last thing we want to do is check for failures, just like we did in our previous tests and functions, et cetera, right? So if you go to the top here, we tested for failures. We, made sure it had a name, all that kind of stuff. So let's check for a few failures here. I'm going to give ourselves some space just so that we have, you can see it on screen. So let's check for a few things. Let's, First, let's require that the product exists. So basically, we want the ID to be correct. So if we only have 5 products and they send in product 99, we want to stop execution. So make sure the product has valid ID. So we'll say require, let's say product ID is greater than 0, and it's also is less than the product count. All right. So next we're going to check that there's enough ether in the transaction. So whenever they, actually, sent this function or called this function, that they sent the right amount of ether. So say require, I'll say actually require that there is enough ether in the transaction. So in the code, we'll say require MSG to value is greater than or equal to, greater than or equal to the product price. All right. Next, we'll say require that the product has not already been purchased. All right, we'll say require bang product. So basically, if product purchase is false, we'll just use the opposite of that. All right, and if it's true, we'll also use the opposite of that. That's what this bang operator means. All right, so also require that the buyer is, is not the seller. So require seller is not MSG.sender. All right, we don't want someone to be able to purchase their own product, okay? And we don't want it to be already purchased. We want it to have a valid, price whenever this gets sent in, all that stuff. All right, so that's all the requirements that we need. Now we can test for all that in our tests. I'm gonna go ahead and clean up the source code here to remove all the extraneous spaces. We'll just compile this, truffle compile. Make sure that we didn't make any syntax errors. All right, compile properly. So now let's go to our tests and let's check for the first failure. All right, the first failure is going to be, let's see, it tries to buy a product that does not exist. Basically, we want to use an invalid ID. All right, so we'll say buy a product that does not exist, i.e. Product must have valid ID. All right, so let's just copy this and say this, take away the results. Purchase product count, let's say like 99, and then should be rejected. All right, let's run the test. All right, so we got some issues here. We got to revert. All right, so I got a little issue here. So let's actually go back into the code. We want to make sure that the product count is this. So not just less than, it can be less than or equal to. All right, so let's save this. I'll rerun the test. All right, like this. All right, and it passes. So let's go back to marketplace tests and let's write some more tests here. We're going to go ahead and just step through these to wrap up this video. So we'll say, let's make sure that we buy with enough ether. Okay, so we'll try to send too little, right? So not enough ether. So we'll just do that like this. We'll just say, right, marketplace purchase product, and we will use a valid ID, but we basically only use like half the amount of ether. So it costs 1 ether, but we're going to send in 0.5, all right? So next thing we want to do is make sure that they try to buy the product from somebody else. Basically, like we're going to try to purchase it twice. And we don't want that to happen. So we're going to do that from the deployer account like this. So say purchase product account. We do it from the deployer. So it's somebody else. It's like, a third party that hasn't even interacted with this transaction yet, but it's already been purchased. So we want it to fail. So we'll check for it that way. All right. The correct amount of ether, all right, should be rejected. The last is we don't want the buyer to be able to buy the product twice. All right. So the buyer can't be the seller essentially. All right, we just basically try to purchase the product again from the buyer to make sure that that won't work. All right, so it should be rejected. All right, so let's just clean up this. I'm gonna try to run the tests, and that should be all that we need for this smart contract. Say truffle test. All right, it works. There you go. That's all the tests, and they're passing. Okay, so that's everything that we need for this marketplace smart contract. This is our complete blockchain backend that we're going to use whenever we build out this full stack application. This is everything we need. So we've got tests for this. It's really important to test your smart contracts before you put them on the blockchain because the code can't change, right? So let's go ahead and deploy these to the blockchain and we'll wrap up this video. So the truffle migrate. All right, it worked. So let's just open the console really quickly. Truffle console. All right, let's just check Let's say marketplace. Actually, let's just copy the code here. We'll say, sorry. Do it like this, boom. All right. There we go, marketplace. All right, it's got an address. All right, cool. So everything works. All right, so that's our smart contracts are on the blockchain now, and we've got everything that we need to start building out the client-side application for this full-stack blockchain app. And that's exactly what we're going to get started doing in the next video. All right, so I hope you all like this video. Be sure to subscribe to the channel if you haven't already, and click the like button down below. And as always, if you want to learn how to become a highly paid blockchain developer, you need to join my free training on my website over at dappuniversity.com/bootcamp. All right, until next time, thanks for watching Dapp University.